What's up, guys? In this video, what I want to do is cover how to add and subtract fractions when you have like denominators. Now, we're going to go and do that by working through 5 different examples to help you understand the concept. I hope you enjoy.
Okay, what I'd like to do is show you how to add fractions. Now, it's very common to add fractions. I always kind of look at, well, kind of like a candy bar, you know? And we always think about that. If I can go and take this, and what this fraction I'm going to do is represent as a bar. And I'm going to break it down into 8 sections. 1, 2, 3, 4, 5, 6, 7. All right, and then I'll break this one out. So what a fraction is, remember, it's a part of a whole. Right? A fraction is a part over a whole. So this says there's 3 parts. So I'll say 1, 2, 3. And this one says there's 1 part. So let's just do here. So if I said I was going to add these 2 together, the 3 parts plus the 1 part out of a total of 8 sections, I am going to have a total of 1, 2, 3, 4, 5. I'm going to have a total of 1, 2, 3, 4. So I have, and it's still out of 8 sections, so I have 4 over 8, which is roughly, if you kind of break this up, which is the same thing as 1/2. So 4/8 is equal to 1/2. All right? And that's where the big distinction. A lot of students will say, oh, no, it's 4 out of 16. No. You don't add your sections. All right? That is your whole numbers. It's part over whole. So how many parts do you have out of the whole? The whole is not going to change, but you can reduce it down to 1/2. All right? We don't need to write there's 8 different sections when we can simplify that to 2 different sections. So that's how you add fractions.
All right, so ladies and gentlemen, just to go back and reminder on subtracting fractions, the one thing that really pains a lot of students when we're adding and subtracting fractions is you have to have the common denominators. All right? So fortunately, in this case, we do have a common denominator, which is 7 and 7. So when you're subtracting fractions, basically all we are doing is applying the operation to the numerator and keeping the denominator as the same. All right? So basically, all I have to do is 4 minus 2, which is 2. So 4 sevenths minus 2 sevenths is going to equal 2 sevenths. OK?
On this problem, we're going to be subtracting fractions now. A couple things to remember when you're looking at fractions, ladies and gentlemen, is you have to remember a fraction has 2 parts. It has a numerator and a denominator. Okay, I'm going to keep on using that verbiage or vocabulary for a while. So just want to make sure you guys understand, what a numerator and denominator are. So let's look at the first fraction here. We have subtracting. And a couple things I looked at when subtracting. First of all, I see a negative 3/5, and I see that the 3 is negative, which is cool. Okay, I understand that. Over here I see, and then it's minus a 4/5. Well, I don't know which one is it, where this negative sign, what am I actually subtracting? Is that, am I subtracting the whole 4/5, or how is this, is it just subtracting the 4 or the 5, or is one of them positive or negative? It's kind of getting a little bit confusing. So one thing that I want you guys to remember, when you're subtracting and adding fraction, or just subtracting we'll deal with, your denominator is always going to remain the same. Okay? It always remains the same. So you're only going to be dealing with your numerators. So when I do a negative 3/5 minus a 4/5, I have a positive 5 on the bottom and a positive 5 on the bottom here. So I'm going to want to keep this as a negative 4 up top here. And I'll kind of explain a little bit more when actually that problem's not going to be the same, but because I'll show you, if I do a negative 3/5 minus 4/5. And what I'm going to do is I'm actually going to be subtracting the tops because I want my numerator to be the same. And a couple other videos you might have seen, it doesn't matter if you make the 4 the negative or the 5 the negative when you're dealing with, adding them. But as you're subtracting, it's probably just making it a lot more confusing for you guys. What I'm trying to say is 3/5. Let's say if I made 4 and a negative 5, now these are not the same. So I can't subtract them because they're not the same. I'd have to get the same denominator, so I'd have to multiply by -1 again. So again, that would get me back to this answer. So I don't know if that was needed or not, but just remember when subtracting, keep the denominators the same, okay? And subtract the top. -3 minus -4. You owe $3, you borrow 4 more, now you owe -7. However, it's not dollars anymore because it's divided by 5. I like improper fractions for those of you that are in the mixed number crowd, which I don't know. So what you do is you divide, how many times is 5 going to -7 without going over? It goes in there 1 time. How many are left over? 2 over your denominator, and that's a negative. Okay, so that's the mixed number. I like all you guys to keep these in this area though. That's how I want your answer. Over here, we have a lot of negative signs now. It's actually kind of like little steps. So first of all, I don't have the same denominator. So what I'm gonna have to do is, I'm gonna have to get the same denominator. Over here, the same denominator is easy. You just subtract the tops. Over here, I don't have the same denominator, so I have to multiply by, I have to multiply by factors to get them to be the same multiplier. So we'll do the easy long way first, just so you guys can see it. Let's write out the factors. 3, 6, 9, 12, 15, 18. You guys can see I'm stopping because I'm doing the work in my head. 5, 10, 15, 20. All right, another way to obtain that is to multiply your 3 times 5, and that'll get you. It doesn't always get you the least, but a lot of times it at least gives you an answer that you can simplify later. So, sorry, I'm talking a little faster again as I get interrupted. Hello.
Hello.
Okay, so to finish up the rest of this problem, what you're going to do is, to get this to be 15, I need to multiply by 3. To get this to be 15, I need to multiply by 5. And notice I'm multiplying by the top and the bottom, because to keep a fraction the same, you have to multiply by the top and the bottom, right? You guys know 1/2? Well, if you multiply by 2 over 2, that equals 2/4, which you guys all know is 1/2. However, if you do 1/2 times 2, just on the bottom, that equals 1/4. 1/4 is not the same as 1/2. I'll try to slow down my talking, sorry. 5 times 8 is 40. 5 times a negative 15 is going to be a negative 15. And then I have 3 times 2 is a negative 6. Minus a negative 6. Over 5 times 3 is 15. All right, now we kind of came up to our problem we had last time here, is we have like this, we have a negative 15 and a positive 15. Well, there's a couple things actually at work. One thing is I'm subtracting a negative. So therefore, that's actually going to, when you have a double negative, you can actually treat those as positive. So I'm actually adding now. And then here, remember, it doesn't matter if it's on the bottom or the top. Let's just put it on the top. It doesn't matter where your fraction, what is negative, the top or the bottom. That means your fraction is actually negative. So therefore, now I can actually do negative 40 plus 6, which will give me a negative 36 over 15. And I look to see if I can factor this out, and I can. I can divide the top and the bottom by 3. 3 goes into the top negative 12 times, and into the bottom 5 times. So make sure you always reduce your fraction, and make sure, guys, when you're dealing with subtract or negative or subtraction signs, just make sure whenever you have 2 negatives together, you can change it to a positive. And whenever you have a negative in front or on the bottom, just put it up on top so you can use your common denominators. And that's how you subtract fractions.
Basically, ladies and gentlemen, the first thing that I just want to go through is basically what I want to do is at least go through as far as adding fractions, all right? And we'll just start with a very basic adding fractions problem. But there's a couple things that also I want to add in with this problem that is also very important that you guys are going to want to make sure you know. So when we're adding, subtracting fractions, very, very important that you understand what I'm saying. Adding and subtracting fractions, we have to make sure that our denominators are the same, okay? In this case, our denominators are the same, which is good. So what I'm simply going to do when I'm adding fractions is all I need to do is just apply the operation to my numerators, and my denominator is going to remain the same. So therefore, this would be 3 plus 3 is 6/4. Now, remember, we're always going to want to leave our fractions in simplest terms. So I want to see, can I reduce this or simplify it? And the way to simplify it is see, like, can I divide out the same number into the numerator and denominator? And both, yes, 2 is divisible into the numerator and denominator, right? So if I divide by 2 on the top and the bottom, 6 divided by 2 is equal to 3, and 4 divided by 2 is 2. So this can be reduced to 3/2. All right? So make sure you guys leave that in its simplest form. What I have here is -1/7 minus 3/7. And basically, when adding and subtracting fractions, Diamond, could you grab my stapler and just put it on your desk so we don't forget it? When subtracting fractions, the main important thing that you guys want to have is to make sure, Max, that we have common denominators. So you can see in this case, I have common denominators of 7, right? Which is good. So when adding and subtracting, the basic idea, what we want to do is we're just going to apply our operations to the numerator, and our denominator is going to remain the same. Now, when dealing with negatives and positives, we're going to want to, even though it doesn't matter where the negative sign is appropriated for a fraction, for instance, -4/2 is equal to -4/2, which is equal to 4 over -2, which is all equal to -2. So it doesn't really matter where I put the negative sign, all right? But for our operations for adding and subtracting, it's going to be helpful to put the negative sign in the numerator, because that's where we're going to be applying our operations. So basically, again, forget about the fraction part. Just think of a negative number minus 3, right? Because we know now that we have denominators, or the denominators are the same, we're just going to write whatever our numerator is over 7. So think about if you owe $1 and you borrow $3 more, therefore you now owe $4. So the answer is -4/7. Okay? You could also rewrite this as an addition problem. -1 plus -3 is -4. Okay?